In this video, we build on what we did last time with angles and different types of points and lines to build nice two-dimensional shapes like triangles, rectangles, trapezoids, but not just build them, but analyze them with perimeter and area. This is some of the most practical math we'll see. Let's get started. So to begin, here I've listed some basic formulas for you to memorize, but it's more important that you understand what's going on here. So first of all, when we're talking about measuring around an object, a two-dimensional space or surface, we're talking about typically the word perimeter, and that word comes from the prefix peri, right? Measuring, that usually means around, and meter is usually the unit of measurement for length. So we're talking about measuring around something. Now, in some cases, though, we're not interested in knowing how much material we need to let's say, fence around a yard, right? That would be perimeter. But instead, we want to know how much grass we need to purchase to cover a lawn, for example. And maybe the lawn is a rectangular shape. That would be area. So when we're talking about coverage for a two-dimensional surface, that's area. But when we're talking about measuring around, that's perimeter, okay? Now, the only type of object or two-dimensional object that has a different name for perimeter is technically a circle. In that case, we describe that as your circumference around, okay, rather than your perimeter. Okay, so let's take a look at our first groupings here. I want to focus on squares, rectangles, and then parallelograms in general. In each of these cases, if you're trying to find the perimeter, it's pretty straightforward. You simply add up all the sides. So for example, for a square, your perimeter would be the side S plus S plus S plus S, or 4 copies of S, okay? In the case of a rectangle, where you have a length and a width, which are not necessarily the same size, right? Unlike the square, you would have 2 copies of the length and 2 copies of the width when you add them all up. So 2L plus 2W. And similarly for the parallelogram in general, 2L plus 2W. Twice the length side and twice the width side. Okay. Now when it comes to a triangle, however, you'll have side 1, side 2, and a base. So you just add up all of those 3 sides, side 1, side 2, plus your base, or side 3 if you prefer to call it that, and that would be your perimeter there. And for a trapezoid, we'll talk more about it in just a moment here, it's going to be base 1 and base 2, which have different measurements. So add up your bases, and then side 1, side 2, so add up your 2 different sides. But in all of those cases, what are you really doing to calculate the perimeter? You're just adding up all of the sides. So in general, that's what we mean by perimeter. Add all side measures. Okay, so if you understand that, there's no need to memorize each of these formulas. It's a simple matter of applying the principle. Okay, now when we come to a circle, however, that requires a little bit more sophistication. To actually calculate this measurement around a circle, for example, if you're trying to get a piece of string to go around a circle, right? Or the amount of pizza crust to go around your pizza pie, that is circumference. And the formula for that is going to be pi. This is our irrational constant pi, which goes on forever, right? But it does not have a pattern that necessarily repeats. So some people memorize lots of digits of pi, but they don't actually ever finish. It doesn't terminate. It's an irrational constant. But typically people remember it as 3.14, roughly. It goes on again forever without any sort of repetition of a pattern. So when we're talking about that pi, it was discovered, it wasn't made up, it was discovered when people started seeing this relationship over and over again between the circumference of a circle and its diameter. In fact, the way it was discovered was they found that if you take the circumference of any circle and divide by its diameter, d, you always keep getting this irrational constant, about 3.14, okay? And so if you incorporate that as a formula, you could say circumference is equal to pi times diameter, but because the diameter of a circle is really twice the radius, right? The radius is half of the diameter. You could also say 2 pi r, okay? So this is one that you will need to memorize, but the other ones, as far as perimeter around any other object which just has a side, a side, a side, another side, you just add up all of the side measurements. Now let's focus, however, on the term area. What do we mean by area? So when we're talking about area or coverage of a two-dimensional shape, when we're dealing with parallelograms, where we have 2 pairs of parallel sides, and go back to a previous video where we described that, a square, a rectangle, those will all be parallelograms in this case. The basic idea is the area should be my base, area would equal my base times my height. So in the first case, if I have a base that is S units long and another height, which is also s units long, that's just s times s, isn't it? And that's where this formula s squared comes into play. It's base times height. For the rectangle, the same idea. If my base here is the length L, and my height here is the width W, then base times height is just L times W. Same thing. And for the parallelogram here, where it's more of your traditional type of parallelogram, where it's more tilted looking, right? If you take your base as L and you take your height, now notice the height is not the slanted part W, it's the height from the altitude rather, from the base to the top. So from here to here, that would be our height, if you will. And this is our base. Your base times your height would be the L times the H. Now that's one that you might need to memorize because some students might want to write L times W, but W is your slanted height. Some people write S there instead. So slanted height is not what we're talking about. We're talking about the distance from the ground, if it was on the ground, to the top of it. Okay, it's altitude, if you will. All right, now will that W play a role? Yes, it'll play a role for perimeter, won't it? But it won't play a role here for area. Okay? Now when we get to we'll skip the trapezoid for a second if you don't mind, but when we get to the triangle, in reality, this is nothing new because if you think about the rectangle, for example, do you notice that there are two triangles that fit inside? Do you see how there's actually one triangle there and another triangle there? So if the area of the entire rectangle was length times width, what would the area of just one of those triangles be? Yeah, half of it, right? Or half the base times the height. So you take your base, you take note of your height, again, from the bottom to the top, and if you were to multiply that, you would get the entire area for the entire rectangle. But since we only want half of that for this triangle, right, we take 1/2 the base times the height. And that might be one that you need to memorize again if that becomes difficult for you to conceptualize each time. Notice again here, I'm not talking about the slanted heights here, 1 and 2, or the sides of the triangle, side 1, side 2. I'm talking about the vertical height from the bottom to the top of that triangle. Now, when we get to trapezoids, you might wonder where in the world does this formula come from? A equals 1/2 times h times parentheses base 1 plus base 2? Huh? Well, again, if you notice here, with the trapezoid, you have one pair of parallel sides. So here's our pair of parallel sides, base 1, base 2, which are not going to be the same length. That's why they're called different bases, base 1 and base 2. And then we have the two slanted sides, don't we? Side 1, side 2. We also have that vertical height from the bottom to the top, from the bottom to the top. That's our vertical height there, okay? So what's actually happening here? Well, you could say I have a rectangle inside, I have two triangles inside, and work it out that way. But you could have also noticed, let me take another color here. Let's try red. That if you hadn't noticed, we could have formed a triangle like this. And what would its area have been? Well, its base would have been B2, and its height would have been h, and its area would be 1/2 the base times the height. But what about the area of the other triangle, this one here? Well, you would have said I have to add that to 1/2 base 1, and that times the height again. Okay? Notice we're not incorporating side 1, side 2, the slanted heights. We're only talking about the vertical distance from the top to the bottom. But do you notice that that's actually equivalent to the equation here? Because if you were to notice they both have a 1/2 h, right? You could also factor that out. It's an algebraic concept of factoring out the greatest common factor, and you get 1/2 h in front and then b1 plus b2. So in other words, in English, it's half the sum of the bases, so adding the bases, times the height. So basically, it's the height times the average of the bases. Maybe that makes more sense for you. All right. The final one that we're going to talk about as far as area is concerned is area of a circle, which you probably will have to memorize again, okay? And the area of a circle is going to be pi, remember that number 3.14 approximately, but your calculator, scientific or graphing, even a basic calculator today usually has a pi button on it. So you're going to take pi times the radius squared. Now it's really important that you remember from your algebra the order in which you do that multiplication. In algebra, you may have remembered we had something called Pemdas, okay? If you studied in a British curriculum, you might have heard BIDMOS. It's the same basic concept, where you have to do your grouping symbol, in this case parentheses, in the British system is brackets, but you want to do your grouping symbol first, which I don't have, and then here's what you want to notice. Exponents are always before multiplication or division. So we have to take the radius and square it first, and then we can multiply, okay? So first things first, take your radius and square it. Secondly, multiply by pi. So don't just go left to right and not think about PEMDAS. You have to always apply that. All right, so what you're going to be doing here is once you know the radius of your circle, you're going to square it, you're going to multiply it by itself, and then multiply that result by whatever pi is. And you'll get an exact answer, maybe it'll be 36 pi. But then you can use your calculator to get an approximation by using that pi button. Okay, so once you have these written down, maybe on flashcards or in your notes very clearly, let's see if we can use them to apply to some problems. Here's one. Find the area of the shaded region. So what do we see in this picture? Take a moment, deep breath, and any negative thoughts you may have, like I never was good at these in school, put that out of your mind. This is a new day, all right? So look at what we have here. It appears that we have a circle, and there's a funky word we're going to introduce here you may have heard before. Inscribed, okay? Inscribed doesn't just mean that I have a circle inside. It's inside in such a way where at each of the corners, right, it's leftmost, rightmost, topmost, bottommost, each of those points are actually on the square itself. So it's inscribed inside of, looks like a square. Now how do I know it's not a rectangle but a square? Well, here's what we can deduce. We know that it's telling me something about the circle, first of all. It's telling me that the circle has a radius r of what? That's right, of 12 units. It didn't tell me what kind of units. These could be inches, feet, miles, we don't know. But it's some type of measurement, of a lengthwise measurement. So 12 units is my r. So what does that mean about my diameter? What do we know about the relationship between the radius of a circle and its diameter? It should be double, good job. 2 times the radius. In other words, 24 units is our diameter. So this entire length here across is 24. Because this is inscribed, that means that 24 is here, down here as well is 24, from here to here. So in other words, this is 24 by 24, isn't it? It's a square that is 24 units by 24 units. Okay, once I know that, now I can attack the problem. I've analyzed the situation, now I'm going to see what they want me to find. They say find the area of the shaded region. So the shaded region would just be this area that they've shaded for us, okay? Well, that sounds kind of weird. How am I supposed to know how to do that, the shaded region? Well, what I can do is find the area of the shapes that I do know. What I see here is we have a square, so I have the area of a square, area of the square, which is containing the area of the circle. So if I wanted the shaded region, what would I need to do with those two areas? You have an idea? If you said subtract, you'd be correct. Because the area of the square would be too much. The area of the circle is not what I want either. I want the area of the square cutting out the circle. And you might do something like this if you're ever doing any tiling in your flooring needs, maybe at your home, okay? Where you're going to do one part a certain tile and another part a different tile. So you might need to know how much tile do I need. So if you're just interested in tiling the shaded region, we just need that amount of tiling, okay, or area. So let's find the area of the square here. How would I do that? Well, area of a square is just side times side. So in this case, that's 24 times 24. And when you do 24 times 24, what did you get? 576. Now keep in mind, if that was in feet, this would be in square feet now, because feet times feet is square feet, or feet squared. Minus the area of the circle. Now what was the formula for area of a circle? That's right, pi r squared. So pi times my radius squared. What is my radius again? Not 24, but rather 12. Good job. So we would need to take 12 times 12 first, right? We talked about that. Pemdas. You have to do the exponent before you multiply. So that's 144. And you could write pi next to it, but that looks a little tacky. Typically, we write pi at the end. That's convention. So if you want to be traditional here, we'd write 144 pi instead. Now this here is what we would call, in math, the exact answer. Because we haven't rounded anything, which means we haven't cut off any decimals, right? But if we want to get what we call the approximate answer, you could go into your calculator and type it directly as we have written here. 576 minus 144 pi. And your calculator will know to multiply here first and then do the subtraction. And when they do, you should end up getting 123.61 if you round the nearest hundredth. And they'll tell you in your homework or in your test where to round. And this would be in your square units, whatever your units are. Area will always be in your square units. This would be what we call the approximate or the rounded answer. And they'll tell you again what they're looking for. So in real life, most of the time, you care about the approximation, right? You want to know, oh, roughly 12 feet, or roughly, in this case, 123 square feet, right? In fact, we would want to round up, right? Get at least 124 square feet. If you ever talk to anyone who does the tiling or the flooring business, they'll usually include a big percentage extra just in case, because they want to make sure that they have enough and they're not, coming up short on the job. Okay, so that is an example of how area could be calculated by noticing what kind of shape you have, what you actually need, and then taking away the part that you do not need. Hopefully that was helpful. Let's head over to our next example. So in this next example, we're now going to be talking more about triangles, okay? In particular, right triangles, okay? So when we're talking about right triangles, we can calculate the perimeter. So in fact, in the pictures that we see here, for example, we have a triangle where one side is A units long on the base, the height is B units long from top to bottom, and then the slanted side is C units long. We could find its perimeter. We just talked about that, right? A plus B plus C, done. We could calculate its area. Its base is A, and its height is letter B, so A times B, and then take half, and you have the area of the triangle, 1/2 the base times the height. But what if you had 2 of the 3 side lengths, and you needed the third? In fact, this is very popular in construction when you're trying to roof something, and you have 2 of the sides, and you want to find the third. So you want to calculate that gradient side, okay? That could be useful information to have. And the way that they go about that is using something called the Pythagorean Theorem, which was discovered by the Greeks a long time ago. So if you're curious, you can check out the video that I posted in your interactive notes. There's a link there as well. And watch all the different places in real life where the Pythagorean Theorem is very useful. Okay, so what did the Pythagorean Theorem say? What did they discover? Well, they discovered that anytime you have a right triangle, meaning there's a 90-degree angle between 2 of the sides, we will have this relationship. A squared plus B squared equals C squared. Now, it is important which one is C, okay? C is called our hypotenuse. C is called our hypotenuse, which means it's the longest side and it's across from the 90-degree angle, okay? Now, which one you call A and which one you call B, not as important. Side 1, side 2 doesn't matter as much. X1, X2 doesn't matter. What matters is that you have C by itself, okay? And this also has to do something with what we call the distance formula if you study in algebra, right? If this is a point and this is a point, we know that the shortest distance between 2 points is a straight line, and we could actually calculate that using the distance formula, which comes from this Pythagorean theorem. So all kinds of uses here. So let's see if we can apply it. If we take it on faith, this is correct, this is the relationship between the 3 sides of a right triangle, how would I calculate side B's length in this picture? Where we have one side of this right triangle, that's the first step, it has to be a right triangle. This is 6 inches long, they tell me, and this is 10 inches on the hypotenuse. So if you think you know how to do it, pause the video and try it yourself. Okay, let's see how you did. So would the Pythagorean theorem apply here? Well, it is a right triangle, so yes, it should apply. So I would take one side, we could call that 6 inches, and we could square it, plus B, which is also in inches, and square it, equals 10 inches getting squared. If you want to just write 6 and 10 and not use the units, that's okay as long as you remember what's going on here in the end, okay? So let's take a look at what happens here. We would end up with 6 times 6, or 36 square inches. So technically this is in square inches, and you'll see what happens at the end. Plus B squared, and 10 times 10 is 100, or 100 square inches, okay? And then you would have to solve this mathematical equation. Now, this is not a linear equation, so it's a little more complicated. One way to solve this degree 2 equation from algebra is to get the squared term by itself and get the number on the other side. So to do that, you can subtract 36 on both sides. Subtracting 36 on the left, it wipes away. On the right, 100 minus 36 is just 64. Now, in math and algebra, we would have said you would now apply the square root property, which would say take the square root of both sides and make sure you use the plus or minus symbol, because you could have positive or negative numbers that get squared to give you the same result. But in this case, you can kind of just think it through. B is just an unknown number, right? We're saying something times itself gives me 64. And in this case, I hope you know what the answer is. The answer is 8, right? In other words, you could have done the square root button on your calculator, the square root of 64, and find that B is in fact equal to 8. And since it was in inches, it will stay in inches. You might have wondered, I thought we had inches squared. Well, when you take the square root of square inches, you're back to inches, okay? So this is a very nice one because our exact answer did not need to be rounded, right? But what if we had, when we subtracted our two numbers, the square root of 65 in the end? Well, that would have required an approximation. You would have had to use your calculator, and it would be 8 point something. It would be a little bit bigger than 8. Okay, so make sure you know what they're asking for in each problem. But in this case, the exact answer is easy to get. All right, so that's the Pythagorean theorem in a nutshell. In the next example, we're going to now apply area, perimeter, and a real-life application. Let's see what we can do. Example 2. A hardware store is selling tile flooring for $2.29 per square foot. It charges $4.29 per square foot for installation, also known as labor. Determine the total cost of hiring them to lay your tile in your 25 by 22 foot room. Okay, so they're giving me the dimensions of our room. So in real life, you'd probably measure that yourself, or you'd look at your plans from your house. And they're telling us something about the room, 25 by 22. This is, for example, your length, and this is your width. So length and width, they're giving you the dimensions of a what? A rectangle. So you could draw a picture of a rectangle. Try to draw it better than mine. Should look nice and have 4 90-degree corners. Okay. So your length here is given to you as 25 feet. Your width here is given to you as 22 feet. And what are they interested in doing? Are we trying to cover this space, which would be area? Or are we trying to go around the space, maybe with crown molding? That would be perimeter. So what are they saying? We would like to lay tile. That is coverage, isn't it? So that would be the area. Okay? So understanding what we need to do, it tells us what equation we'll need to build. Okay? So in this case, since we're talking about coverage, we're talking area. So in order to figure out how much this would cost, maybe you already know how to do it, in which case please pause the video and go ahead and try it. Okay? To figure out how much this would cost, I would need to find the total area. So for my cost, I'm going to need to know my total area. And in this case, they're in feet originally, so this would be in square feet. So I need my total area in square feet times my price per square foot. And this is where things get interesting. If you went to the store and instead of square feet, they were selling it by square yards, but you'd measured in feet, you would have to make a conversion somewhere. And we're going to talk about how to do that in the next example. Okay? But in this case, since they're telling us the price in square feet and we're measuring in feet, we should be able to handle this. So first, let's calculate our total area. How do I get the area of a rectangle? That's right, length times width. So when you do 25 times 22, what do you get? Yep, that is correct. You should have gotten a total of 550 square feet. So you could go to the store now, you could say to the people helping you, I need 550 square feet. And again, we're going to assume for right now, for practical purposes, convenience really, that we're only buying the exact amount we need. But in reality, you should usually buy extra, and they'd tell you that when you get to the store. Okay, so 550 square feet is the exact dimensions area. And then we need to figure out what is the price per square foot. Now, assuming we're allowing them to install it, we don't just have to pay for the flooring, which is $2.29 per square foot, but we also have to pay for the labor, unless we want to shop around or unless we want to do it ourselves for someone else to do it. All right, so what is the total price per square foot? It would be $2.29 for the actual tile, plus it would be $4.29 for the labor or the install. Okay, so when I add that together, I should be getting $6.58. That's the price per square foot. So that's the total for labor and tile. So we're talking about $6.58 per square foot. Now, if you notice what's going to happen here, when you multiply square feet, let's look at the units for a moment. Square feet times something dollars, right, over square feet, per means over, right? The square feet will cancel, and you will just get the dollar amount that you owe, okay? So when you do this multiplication, we should have our answer, and what did you get? Did you get $3,619? That's what I got, okay? Now, if you think that's too expensive, notice most of the cost was the labor. So if you could take out the people doing it for you and do it yourself, maybe watch some videos online to get some tutorial help, or get some friends and maybe give them some pizza if you trust their labor, you could probably get this price a lot down. In fact, you could calculate the price for just the tile itself by deleting the 429 and replacing 658 with 229, right? And that would give you that price, okay? All right, so let's talk about what to do now. So that was a complicated one. I hope not terribly complicated, but for some of us it might be a little bit tricky to get used to, okay? But what would we do if we had to make a conversion, right? If we had to go from feet to yards, square feet to square yards. Don't panic, don't just pull out your app on your phone. Let's see if we can do this by hand. What is this called? This is called converting units or dimensional analysis. And this is a skill that if you're not really great at it, you want to practice becoming great at it, especially not only for doing work like this around the house, but if you're going to go into nursing or if you're ever going to give medications to yourself or a child, you might have to adjust them, right, based on converting. And this is a very important skill. So let's look at, for example, a conversion factor like 3 feet equals 1 yard. Okay, so if you know that that's a conversion factor, how could I incorporate that in the next problem? Let's take a look. Example 3 says, can you convert using conversion factors? And again, we'll typically give you these conversion factors on your test, so you don't have to memorize all of them, but we want to make sure you know how to use conversion factors to go from one unit to another. All right, so what do we have here? We have 153 square feet, and we would like to convert that into square yards. Okay, so if this was what we had like the last situation where someone has calculated the dimensions of a space and they've multiplied length times width and created this square footage, they could have from the very beginning switched from feet to yards, right? Because we know that 3 feet equals 1 yard. So that's our conversion factor here. But if you did not do that conversion at the beginning, but instead you take your final answer and you bring that to the store and they are selling their tile in square yards, or maybe this is too much for tile probably, but maybe this is your grass or whatever it is that you're covering an outdoor space with. If you give them your measurement in square feet and they're selling in square yards, how would you make the conversion on the spot without using any technology? Let's say the power went out that day, all right? So what would you need to do here? Well, you could notice that instead of regular linear feet, which measures around, like perimeter, you need square feet. So could we change 3 feet into something that is square feet? Well, in math, the way we could do that when we have an equation is we can actually square both sides. And this also works if you were going to cubic units, like cubic centimeters. You'll use that in medications, some cc's, right? And so the idea here is take each side and raise it to the power that you're interested in. So I'm interested in this case in square feet, so I'm going to square this side, and I'm also going to have to square the other side. What you do to one side of an equation, you do to the other. Well, 3 feet times 3 feet is 9 square feet, or 9 feet squared. 1 times 1 is still 1, isn't it? So that's 1 square yard, or 1 yard squared. So this is our new conversion factor, right? We've basically got a new conversion factor by squaring the old. Okay, why is this helpful? Well, if I want to go from 153 square feet into square yards, one trick people do sometimes is they just remember small to large divide, large to small multiply. Okay, so if you can memorize that, small to large divide, large to small multiply. But in this case, it's better if you understand how to do a dimensional analysis proportion. Let me show you what I mean. So you start off with 153 square feet. Okay, and I'm going to put that in parentheses. What would I need to multiply that by in order to get into something that has square yards? Okay, well, if I notice here that I have a conversion factor of 9 square feet equals 1 square yard, did you know that if something is equal to itself, you can stack them on top of each other and they're equal to 1? So did you know you could write 9 square feet over 1 square yard? And you could also have written 1 square yard over 9 square feet, and that is equal to 1? Yeah, because if two things are equal to themselves, you can put one on top of the other and they're equal to 1, which means you can multiply by them. You can multiply by 1 whenever you want. Which of these would be more helpful to us if we want to get rid of square feet? Well, it would be the one with the square feet in the bottom, right? It would be this one here. So I would take 1 square yard over 9 square feet. Okay, why would that be helpful? Because square feet would cancel with square feet, and I'd be left with square yards. So what happens here? What am I really doing? 153 over 1 is being multiplied by 1 over 9. That's a fancy way of saying I'm dividing 153 by 9. And that is because I'm going from a smaller unit of square feet to a larger unit of square yards. So what is 153 divided by 9? Did you get 17? Yeah, so 17 square yards is my answer. In this case, we get a nice exact answer. Oftentimes, though, you'll get approximate answers with your calculator. Let's have you try the other one on your own. See if you can do it. How would you go from 15.2 square yards into square feet? Let's see how you did. So you took 15.2, let's say yards squared, square yard, same thing. What would you need to multiply by in order to get into square feet, or feet squared? Well, you'd want to multiply by something where yards squared is in the bottom, right? So that's your little clue. So looking here at our conversion factor, it would be this one, wouldn't it? 9 square feet over 1 square yard. So in this case, it's yards squareds cancel, and I have 15.2 on top times 9. So we're multiplying. And again, you could have remembered large is small and multiply. 15.2 times 9, and that should give you approximately 136.8. 136.8. Okay, now I've actually included a video here for you to get more practice. In your interactive notes, I encourage you to go to the link or just click on it in the interactive notes from another website, and it'll show you how you can use these conversion factors in dosages like medications or in any type of conversion. Maybe you're talking about your weight from one unit of measurement to another. If you've ever traveled, usually they are in the metric system and you might need to make a conversion. So these conversion factors are really important that you know how to do them by hand, not just because sometimes the power goes out and you can't use the app on your phone, but also because if you're in a situation like a nurse, for example, and you are actually checking the medication before you give to your patient, it is important that you can do math on the fly. Double check yourself, of course, but you can compare and make sure that something is reasonable and you're not going to give too much or too little of something. All right? Well, I hope this was helpful. If you have any questions, feel free to reach out to me. But as always, happy practicing, because math is not a spectator sport. I'll see you next time.